Okay. All right. Well, thank you all very much for showing up. Hopefully, we'll have a really interesting conversation about the future of climate energy. Let me start off with sort of the scariest climate plot in the world. All right. So this plot, the global average temperature over 30,000 years, and we're at the arrow, and it goes 20,000 years in the past, 10,000 years in the future. You'll notice there's something really weird going on right now. So the temperature really abruptly rising. The heavy snowstorms shut down. What's going on? The minute planet date. Yeah, it's fossil fuels. So we're burning fossil fuels. We dump the carbon dioxide straight in the atmosphere. Carbon dioxide is worse heat, climate wars. This is not actually complicated science. It's very simple. Now, if you look at how much though, and the other thing I like to point out to students is this fossil fuel era that we're living in is really going to be a very short period in the sweeping history of humanity. Humans have lived on Earth for a few 100,000 years, and hopefully for a very long time in the future. And only a couple hundred years of the fossil fuel era. You happen to live there. But there are consequences of it. And one of the consequences is that we're going to warm the climate by about 3 degrees Celsius. It's about 5 degrees Fahrenheit. Multiply by 2 is a good rule of thumb. It's a little bit less than that. So 3 degrees Celsius is about 5 degrees Fahrenheit. Now, people often ask me, this is a clearly reasonable question, who cares? This morning's 25 degrees Fahrenheit cooler than it is now. Why should I care about 5 degrees Fahrenheit of warmth? And the answer is that this is global average. This is not local warming. All of your intuition is based on local temperature changes. The global average is very, very stable. And what's seen to these small changes in the global average corresponds to huge changes in what the Earth looks like. And so let me give you an example. If we look at that, that's a 5 degrees Celsius change, about 9 degrees Fahrenheit. And this is a difference between an ice age and the world we live in. So we were in an ice age 20,000 years ago. 10,000 years ago, we were out of the ice age. And that's about 9 degrees Fahrenheit. So when we talk about 3 degrees Celsius, 5 degrees Fahrenheit, that's 50 or 60% of an ice age during its history. That is enough to completely remake the planet. And let me also point out, for you students, this is your life. I don't plan on living to the end of the century, but you guys, you probably will. You're going to live through this. And if it's not a good ride, you're the ones who are going to suffer, not the people in Washington who are, geriatrics. They don't have skin to gain. You guys have skin in the game. Or hell, we are right here, which is about 1.3 degrees above pre-industrial. And so this is 25% of an ice age. So when I say, if I tell you we form 1.3 degrees, in your mind you're thinking, who cares? If I say we form 25% of an ice age, that's a lot of warming. And that's why, when you look at the news, you see things that are amazing. Hurricane Harvey, I listed that. College Station where I live is about 50 miles from Houston. We got a lot of rain. I did assure you of that. And, so these things happen when we say, I've never seen this before. That's 25% of an ice age. And we're heading for a lot more sort of on business as usual trajectory. All right, now, what are we going to do about this? That's really a question, okay? It's not that 3 degrees is some magic number saying that. We really need to think about what our policies should be. Now, when you look at something like this, there are really 2 options we have. All right, so one option is we can try to adapt to the changes. And adaptation is basically answering the question, how do you live with 3 degrees Celsius or more? As we'll talk a little more about that in a second. And then the other option was mitigation. Try to stop the climate from warming. Now, I should emphasize these are not mutually exclusive options. In fact, we really need to do both of them. We need to adapt to the warming you can't avoid, and and I would argue we need to slow down the warming as much as possible, because that makes adaptation easier. And why is adaptation difficult to do? Because I make the argument that adaptation is hard, and mitigation is actually not hard. It's pretty hard. It's not hard. It's not technically hard. So why is that a big? So the main problem is block by grab block on that too. People don't want to pay more. That's basically the issue. So let me give you one example. Or actually, I'll give you a preface, like an example. If you don't talk about adaptation, there's this idea of rugged individual Americans doing things in their F-150 to avoid the impacts of climate change. And certainly, individuals can do a lot of things to avoid climate change. But effective adaptation is when required widespread, community-wide actions. Things like building a seawall. No one in the F-150 is going to build a seawall. Okay, you need the entire community to agree and build a seawall. This one has to pay for it. What you find out is nobody wants to pay for adaptation. So let me give you an example. 2008, Hurricane Ike executed a very close near miss of Houston. If it had been the track had done a little bit of different, we would have gotten 20 feet of storm surge up Galveston Bay and into the Houston Ship Channel. And if we've ever seen a picture of it, all these giant tanks of chemicals, whoever's said it would have been America's Chernobyl, because all that stuff we got released, all those millions and millions of gallons of chemicals. So the Ike is now estimated about $60 billion. And just a few weeks ago, Congress said they would pay $5 million of $60 billion. Texas can't afford it. It's really only the federal government that has the money to do this. And people, so the problem with adaptation is, who's going to pay for it? How many people here want, I'm not literally asking you this, but I mean, how many people want to spend their tax dollars to build a seawall in Houston? Well, Houston will probably vote for it, but is somebody in Idaho going to vote for it? And it's even worse is, who's going to vote to pay for a seawall around Bangladesh? If you're a U.S. senator, are you going to vote for that? I can already see the attack ads. Senator Cornyn, one of Texas senators, he voted to send money to Bangladesh. If you elect me, I'm going to keep America's money here. I'm going to cut your taxes. I mean, it is going to be very hard to sell adaptation because it's got to be rich people paying to help poor people adapt. That's the most effective adaptation. That's going to be a hard sell politically. So adaptation is going to be ugly because of high cost. Rich and politically well-connected people will adapt to the extent they can adapt. And the poor are going to suffer. That's all. That's going to be the law. That's how they'll adapt. They'll adapt by suffering. And so I think that we need to adapt, but we can't really rely on it. It's too problematic. So the other option is let's stop climate change. All right, let's stop. So that's what we're talking about mitigation. That's what we mean. That basically means you rebuild our energy infrastructure away from fossil fuels and towards renewable energy. And as I'll argue here, that actually saves money. So not only does it not cost anything, it actually saves money. And this is something I read about 3.5 years ago, which is aged light well, says it has, I believe that you are living through an energy revolution. So if you don't know you're living through an energy revolution, you are. This is every bit as significant as any energy revolution that humanity has ever experienced. And the great Bill McKibben, I listened to him give the talk a few weeks ago. He said it used to be that people thought of renewable energy like solar energy as the Whole Foods of energy. You have Whole Foods, very expensive, good stuff, but very expensive. And most people can't afford Whole Foods. I can't afford it. But it's really become the Costco of energy. Now it's cheap and available for masses. And that's really the revolution. The price of solar and the wind has plummeted. And as a result, if you look at the market, solar and wind and batteries are basically the only thing people are installing. So let me show you a plot here. The x-axis is fuel type. It's so solar, battery, wind, gas, and other. And the y-axis is how much energy developers are planning to hook up to the ERCOT grid. ERCOT's the Electric Reliability Council of Texas. They run the Texas grid. And if you ask the question, what do people, these are energy developers, they're not bird stock wearing yippies driving around in Vanagon to fish hunters. This is what they're hooking up. Okay, it is mostly solar and batteries. That's 80%. Because hook up solar and batteries, you're just mint to make. Wind is 10%. Gas is a little bit less than 10%. So renewable energy is 90% of the power. 90% of what gets hooked up. is renewable energy. This is the market pushing us this pressure because they are the cheapest energy sources we have. Now, before this is a meme. It's Spider-Man. So you see Mary Jane talking to Peter Parker, saying, "Tell me the truth. I'm ready to hear it." And Peter says, "Everyone already knows renewables are intermittent." And then she bursts into tears. To be clear, I'm a geoscientist. I know the sun goes down at night. So we understand that solar and wind are variable energy sources. Okay. So let me explain to you how they say this much and why the cheapest energy one is one that's dominated by wind and solar. And this was a thought experiment. Let's imagine you need to generate a gigawatt of power. So a gigawatt's like one big coal-fired power plant, or like half of Hoover Dam. Hoover Dam's a few gigawatts. So that's a lot of power. But a power burn. Now we have two options to do this. So one option is we just build a gigawatt of natural gas and just run it continuously. The other option is you build the same gigawatt of natural gas. You also build a lot of wind and solar. Let's ask, how many people think the just natural gas is cheaper? Raise your hand if you think that's a cheaper energy source. Just all natural gas. Even nobody believes that. There's almost right around. The other option is the other one. How many people think that's cheaper? All right, interesting. Because I think intuitively, you look at the ones all natural gas and say it's gotten cheaper, but it's not. I want to explain why it's not cheaper. So certainly, if you're building power, when you construct it, you have to spend more if you're building natural gas plus solar, because both of them are building natural gas. But the solar one is also building a lot of solar. So construction for nothing. Once you start operating it, it's much cheaper to operate the natural gas plus the solar. The reason is because whenever the sun's shining, you're going to buy natural gas. And when you buy electricity from natural gas, a lot of your expenses are the natural gas. And so over time, every year you save money, operating expenses. You spend more to build it, you save money in operating expenses. And if you sort of do a discounted analysis and ask what's the levelized cost of energy, you see it's cheaper to actually run gas and solar together. That's a cheaper energy source than running just gas, even though you have to build more stuff to begin. In fact, this explains this plot. So the one on the left is China, shows wind plus solar on China. It's exponentially increasing. The one on the right is wind and solar for India. It's also exponentially increasing. And it's exponentially increasing because it saves the money. It literally saves the money. And so this is really the future. This is the future of the cheapest energy we have to start building renewable energy. Now, what I show you is just a very quick schematic. I basically made up numbers. I said take a picture of this or watch the video if you want to see actual engineering estimates of how to rebuild the U.S. grid that's mainly renewable energy that costs about the same as they're paying now. So we can do this. We certainly can do this. And I'll just very quickly say other benefits: less air pollution, saves tens of thousands of lives, is there not burning fossil fuels, and geopolitical stability. Fossil fuels really make us less safe in the world. I won't talk more about that. Feel free to ask questions about that. I can give you some examples on that. All right, so let us finish up with a point about, your reaction very well could be, well, if it's cheaper, why are we, what's the problem? Why are we just doing it? The answer is that we currently have an administration that doesn't want to let the transition occur. They don't want to let the market wipe out fossil fuels. So just a few days ago, October 7th, this was in the New York Times or Washington Post. White House offers concierge service to fossil fuel firms, while simultaneously slowing down or blocking solar and wind projects. And this was saying it happened just late August. The Trump administration shut down an almost finished wind farm off the coast of Rhode Island, I think. And so you've got an administration that's actively working to stop the transition. So I'll wrap up here. All right. 7 seconds left. So adaptation, I think Dr. Burgess and I will agree we need to do it. It's absolutely required because we can't avoid all climate change, but we can't really rely on this. And instead, we should be working to minimize how much climate change we have to adapt. And we have the technology to do this at basically zero cost, at least almost entirely. And switching renewables is really the all chocolate dessert. It's better and it's cheaper. And finally, just to emphasize, for those of you who are born in the 2000s, this is your future. Okay, so these people are messing with your future. So, get angry. I tell people don't get depressed about climate change. Get mad.
We're not debating one proposition. We can agree on some things, we can disagree on other things. There's lots of things we agree on. And one of the obvious ones, or hopefully obvious ones to get out of the way, is that climate change is obviously real. It's obviously caused by humans, specifically human fossil emissions, right? This is a plot from Professor Dessler's blog with Steve Hausfather, which I recommend subscribing to, The Climate Break, where you can see the orange and black is warming, and the gray is emissions, and the green is natural, right? So it is us. Well, the other side of the coin that I think is really important is that we need cheap energy to run our society. And if you think about elements of our societal well-being that are sensitive to climate, many, if not most of them, are also very sensitive to cheap energy. This is a plot of just looking at electricity, but you can make a similar plot for all energy, of energy consumption per capita and income per capita. And the person who made this graph very helpfully points out that there's no such thing as a high-income, low-energy country, and that's not a trivial thing. And I would go further to argue that development and the cheap energy we need to have development has, at least historically, and probably for the foreseeable future, been much more important to climate-sensitive outcomes than climate change. Just to give one example, this is a plot of crop yields going back to 1960 for cereals on average. And you can see the steady rise, right? In the 60s, people were writing books saying the population bomb was going to cause 65 million Americans to starve. India and Britain were going to collapse, was the prediction. This scared a bunch of people into passing eugenic policies like China's one-child policy, which led to 100 million close abortions. And what saved us was the technology-driven green revolution, which caused yields to go steadily up. And then if you look forward, this is an estimate of future yields, accounting for adaptation, but not future technology. So if we adapt as though we have with today's technologies, and in the free-ish degree scenario that Professor Dessler talked about as the blue one, RCB 4.5, you do get a little bit less yield on average with lots of uncertainty compared to a world without warming. But the world without warming is also a world with cheap energy but no warming. So that's not a trivial assumption to make. But one area where I agree with Professor Dessler is there are a lot of ways where we can reduce our emissions and benefit our economy. This is a plot from the IPCC's most recent report where each row is some action that you can take to reduce emissions. The length of the bar is how much emissions production you get, and the color represents the cost. And everything that's blue is less than free. We benefit our economy by switching electricity on the margins to solar, wind, by increasing energy efficiency. And we should do those things. But as you'll notice, they don't get us all the way there, right? They get us maybe 10 gigatons out of roughly 50. They don't get us to net zero. But the way you get more of these things is science. So another thing I suspect that Professor Dessler and I agree on is you should not cut science. If you want to prioritize the economy over reducing emissions, then I think you want more science, not less. Fossil fuels are going to be... I think I'm stepping on the cord. It's covering that stash. Sorry. Fossil fuels are going to be with us for a long time. This is a plot of global oil, coal, and gas. And then in the bottom, you can see renewables. Renewables have 50x'd in the 21st century, so they're increasing dramatically, but they still haven't cracked 20% of global energy use. And if you're a country like America that has a large comparative advantage in fossil fuels compared to, say, China, which has more of a comparative advantage in renewables, there is an argument for maintaining our dominance in fossil fuels as long as the fossil fuel economy exists. Although another area where I would agree with Professor Dessler is there's not an argument for canceling, large solar wind projects that are already built. All in all, I would say this suggests that we want an all of the above approach where we invest heavily in R&D and we pursue all types of energy, at least for the next several decades, that are market competitive. And most voters agree with that. This is a poll conducted by Roger Fieldy Jr. and Marichi Shira. Well, they found that just over half of voters in their survey support an all of the above approach, compared to about a quarter each that support a rapid green transition versus the, push the brakes and cancel all the renewables. I agree with Professor Dessler that there's a false dichotomy, mitigation versus adaptation. We need to do both, right? And certainly we need to go all in on the areas of mitigation that save us money and make our economy better. But if you're talking about the expensive types of adaptation or the expensive types of mitigation, we probably do need to do some of both. But the expensive types of adaptation are going to be the main things that determine our well-being in the face of climate change on the scale of several decades, at least globally, and on the local scale, probably for even longer. Let me walk you through that. And I make this point because of narratives like this one from Bill Nye and CNN after the catastrophic floods in Texas, where he said, so what are we going to do about it is the ancient question, and it would be to stop burning fossil fuels. When you're in a hole, stop digging, and so on. And its implication, if you're just listening to what he's saying, you don't know the context, is that if the good people of Texas turned off all their fossil fuels, then they wouldn't have the kinds of floods that they saw. And there's two problems with that. One is that we're about 1.3 degrees C warmer, as Professor Dessler said. Even if we achieve our 1.5 degree target, which nobody thinks we're on base to achieve, we're still going to be as warm or warmer as we are today for the rest of the century. So we're going to have to deal with the sorts of floods that we're seeing in Texas today, even in the best case mitigation scenario for the rest of the century. And we're going to have to deal with the fires that we see in the West, et cetera, et cetera. So we need to adapt no matter what we do with mitigation. But I think Bill Nye here is committing a broader fallacy that I call the stopping smoking cures cancer fallacy, right? Nobody would dispute the fact that smoking causes lung cancer, but if you have lung cancer, you need cancer treatment. Stopping smoking is not going to treat your cancer. And I think there's somewhat of an analogy to climate change, where there's no question that fossil fuels and greenhouse gas emissions cause climate change. But once you have climate change and you have the things that come with it, the way that you help your society deal with it is you adapt. Whereas just mitigating again doesn't get you back to where you are today for longer than a century. To put a finer point on it, here's a simple thought exercise. So by way of background, the temperature anomalies, how much warmer we are compared to pre-industrial, is roughly linear in our cumulative emissions, the sum of our greenhouse gas emissions, since the beginning of the Industrial Revolution, or beginning of human history. So our annual emissions currently are about 2% of our cumulative emissions, and emissions in the United States are about 13% of global emissions. So if you all got angry about things like wildfires in the West and floods in Texas, and the American government said, all right, we're going to completely eliminate U.S. emissions overnight, the expected temperature anomaly next year would go from 1.3 degrees C to 1.297 degrees C, right? And you would probably still be dealing with the sorts of impacts that we're already dealing with. Let's think about Louisiana, which only accounts for 4% of U.S. emissions, right? So multiply that by that 0.26% by 4.04, and you get into a smaller number. Put that into perspective with adaptation. New Orleans, and this is why I picked Louisiana, New Orleans had two devastating hurricanes. Well, you've probably all heard of Hurricane Katrina in 2005, and there was Hurricane Ida in 2021. Now, there were some climatological differences, for example, related to storm surge, that made those not exactly the same, but they were both very strong, similarly strong storms that hit the New Orleans area. And Ida did much less damage and much less death, in large part because there was a part lesson that's overlearned after Katrina, and New Orleans did things like improve its levees, which is a form of adaptation. They could have completely eliminated their emissions in 2005 and done basically nothing for the risk of that second hurricane. And there are other stark adaptation successes too in the U.S. For example, there's been a 75% estimated reduction in mortality rates from days hotter than 80 degrees Fahrenheit since the 1960s, largely due to the proliferation of air industry. Again, we're not talking about the mitigation stuff that's less than free, right? That we should just do. We should let the market, you can have a debate about whether or not we should subsidize, renewables at the same rate we used to now that we're competitive, but we certainly shouldn't step up, right? But we're talking about the expensive stuff. As an economist, I find the narrative that, mitigation is easy if we just have the political will and adaptation is hard is almost backwards in terms of the incentives. So with adaptation, you have benefits that are more geographically matched to costs and more temporally matched to costs. Whereas mitigation, if it's costly, you have concentrated costs and diffuse benefits, not just over space, but also over time. Now, that doesn't mean we shouldn't do mitigation, right? That's the tragedy of the commons, right? That's why mitigation is so politically hard. This is a plot showing how adaptation has often exceeded expectations. So in what would be your top right is a plot from a paper by Fournette and Thayen, where I'm plotting their estimate of within a 200-kilometer radius globally of disaster events, climate-related hazards, so including heat waves, compared to damage compared to GDP and death compared to population, and you can see that they've fallen quite dramatically, right? So on average, something like 80%. The areas where technology is driving mitigation are also exceeding expectations. That's the bottom right. The solar PV costs, was fallen faster than the IPCC projected it would. But our overall mitigation is still lagging behind targets, the verbally stated policies compared to the 1.5 and 2 degrees consistent scenarios. And if you look at overall global CO2 emissions divided by GDP, so the emissions intensity of our GDP, it's basically been a straight line decrease since the 60s. And you can squint really hard and see if there's an inflection after the UNFCCC, Kyoto, or Paris. Another reason why I think it's important to call out the importance of adaptation and the importance of development to adaptation is that you can imagine ways to do mitigation that are costly. So here are 3 recent estimates of the social costs of carbon, which in economic theory is what you might want to make the carbon price, assuming that you've estimated both sides of the ledger, right? And the top one, for example, is closely related to the one that was used by the Biden administration in their cost-benefit analysis through the EPA. So it wasn't the carbon tax, but they were using that price and cost-benefit analysis. But if you apply that as a carbon tax, you would quintuple the price of coal, which is more than half of China's energy. Do we really think that would be welfare and prudent? For perspective, the IMF estimates that if you increase oil prices by 10%, you reduce global growth by 0.1%, 0.2%. If you increase global GDP per capita by 1%, you on average reduce death and damage rates by about 0.5%, according to the economic studies. So if you quintupled coal prices, what do you think you do to climate-sensitive outputs? I wager that you might make them a lot worse. Lastly, I want to respond to there have been some very interesting studies that have cast doubt on the feasibility of adaptation by quantifying the marginal sensitivity. Basically, how sensitive on the margins is a particular outcome like crop yields or output to temperature or some other climate variable, and has that sensitivity changed over time? The idea is if the sensitivity's gone down, then we're adapting, and if it hasn't, then we haven't adapted. And as you can see, all of these different estimates that orange blue are ones where we have not significantly reduced our sensitivity. But I wonder if that might be missing the forest for the trees. So, for example, Brazilian crop yields, soy and maize, their sensitivity has increased by this measure, but Brazilian crop yields have tripled since the 70s because of things that are downstream in economic development, like fertilizer use and mechanization, and other type gains that don't show up in the sensitivity. And in fact, that's the pattern that you see if you look across these all these measures in macro scale. So cereal yields are going up everywhere, a little bit more slowly in Africa. GE per capita is going up everywhere, again, a little bit more slowly in Africa. Deaths, went up sharply with COVID, but overall deaths from all causes are going down. Heat and cold exposure deaths are going down, actually, especially in high middle income countries, because of cold deaths are going down. Cold death, there are actually much more cold death than heat death. Interpersonal violence is going down. Conflict and terrorism bounces around, but the overall multi-decadal trends are down. And self-harm trends are down, but most slowly in high-income countries. Some of that is social media. Some that I worry is the apocalyptic narratives we're feeding our young people all the time about not just climate, but every other issue, despite the fact that this is the safest, most prosperous time ever and place ever to be alive. And lastly, I just want to close with, I guess, a provocation to both sides to say that, we have policy debates in this country, and that's important. What this country does matters, right? That I'm from Canada. We often joke that Americans think that you're the center of the universe, but you kind of are, okay? But the White House is not the center of the incentives and market forces for even U.S. emissions. So on the left panel, what I'm showing there is that U.S. greenhouse gas emissions have basically been declining at 1.1% a year since the Bush administration. The blue projection at the bottom is what happens if Biden's policies had worked perfectly, which we know it didn't. And red is what happens if Trump gets through everything Biden ever did. And dashed blue, which is fairly different from red, is what happens if Biden's policies work perfectly, but we don't build power lines faster, right? And so the point is, the market is pushing us in a direction of less coal, more oil and gas, more renewables. We should have these debates about climate policy, but let's stop on both sides pretending that the fate of the planet and the economy hangs in the balance, and let's follow the Heterodox Academy way. Thank you. Well, that's a good question. I think it depends on where you are, right? So the Netherlands is an example of where they have adapted to that situation. I don't think that you're going to build, you're not going to solve the problem in Miami, which is, you're the physical scientist, but it's also a line of stone, right? Like with a huge coastline.
Yeah, so the point is that water would go under a wall. It would go right like it's went to a sponge.
But it also depends on the time scale, right? Some of the catastrophic sea level rise scenarios occur over hundreds of years, right? And so then people might retreat from some areas, right? Which may need to happen. And in fact, the insurance rates, right? There's an argument among free market techno optimists. There's an argument that that part of the problem in places like California is that we're not letting insurance prices go up as much as they should in a few areas, and because they're not allowed to go up as much as they should in a few really high risk areas, they're cutting off much larger areas from the market because the companies don't want to insure there. So yeah, I guess in some places the solution will be like the Netherlands. In some places, and if it gets bad enough for a large enough population, I do think governments will step up like they have for, we bailed out the banks, right, at a huge price tag. And in areas where physically seawalls aren't going to work, you're going to find some other solution. And in a few areas, probably that is going to be managed retreat.
Yeah, I'll just add to that. So I was talking to my class on last week, and I said, what sounds really boring? Insurance. It's not boring? Insurance. The world runs off insurance, and climate change is absolutely hammering the insurance market. Once the insurance market fails, our economy basically is going to fail. So if you're looking for a career, insurance. It sounds boring, but seriously, it's not. So I guess here's when I hear people talk about adaptation. I don't mean you, but I mean other people. I think it's often used by people to kick the can down the road. In other words, people say, we'll adapt to climate change. We don't have to worry about it. And again, I'm not talking about you, but I have debated people
Sure.
in the past who basically just made that argument. Humans have always adapted. Climate change will adapt. But I mean, and it's essentially an excuse to do none. And so I think it's important, I think, to discriminate good faith adaptation from basically delay adaptation, equal this sort of narrative of delay. I do think who's going to pay for it is really an interesting question. And my worry is let me tell you a story. So in Texas, 70% of the prisoners are not in air conditioned buildings, and that's pretty unpleasant. I mean, if you've ever been through a Texas summer, being inside a concrete building that doesn't have air conditioning in the summer is bad. And they didn't want to they didn't want to spend the money to air condition, and instead of spending the money, they essentially normalized suffering. It's like, these people are prisoners. What do they think? They think this is gonna be the Ritz? It's jail. You commit the crime, you're gonna, you do the time. It's not supposed to be pleasant. Come on, these people get what they deserve. Which, I mean, that's a terrible argument, by the way. I'm not advocating, make it clear. It's not an argument I make. It's the argument that people are making and I worry that instead of adapting, we're just going to normalize the suffering of people that can't afford to adapt. You look at these homeless people in Phoenix. And Phoenix is a super well-adapted city. People really don't die from heat there unless you're homeless. And it's like, oh, they're homeless. If they don't like the heat, they should move somewhere else. You get a job. And I'm very worried that adaptation is going to reveal this really ugly underside of humanity when we don't help the people that can't afford to do it.
Yeah, so really, really interesting points. A couple of reflections on that. One is that I think that the argument that you were describing that some people make in bad faith that we should do adaptation because really we just don't want to mitigate. I think that there's a reactionary version against that sort of makes adaptation taboo, right? One of my collaborators wrote a paper, I think in 2007, called "Lifting the Taboo on Adaptation," and in some circles, I think that the taboo is still there. So again, I'm all for both. I just want to lift the taboo on adaptation, especially given that I think it is the thing that's going to make our lives better on the scale of our lifetimes. In terms of the who's going to pay, again, I think it's really worth separating the stuff that's expensive in both mitigation and adaptation from the stuff that's cheap, right? The stuff that's cheap is going to get done, and even if today's government doesn't want to do the cheap renewable stuff, the market eventually is going to push it. In terms of the expensive stuff, I have some of the concerns you have about adaptation, but I also have some concerns about mitigation. I mean, there's some people in academia who think we need to have degrowth, right, for the sake of mitigation. I don't think that would be very good for the poor. The answer to that is usually, well, we'll degrow and we'll share better. And one thing I showed to my students when I used to teach environmental and macro down at CU is a plot showing the 20th percentile income of every country is super tightly correlated to the average income of every country. And I would say, look, you're telling me that you want to live in a world that we've never lived in anywhere before. You better have a damn good answer for how you're going to do it. And it better not sound like the system of government that probably killed more people than any other system of government in world history, which is communism, right? And then the other area where I just think it gets really tricky is we may just have really ugly trade-offs. So another example I used to give my students is, we moved from the 2-degree target to the 1.5-degree target, not really for any kind of scientific reason about feasibility, but because the small island developing states like the Marshall Islands and the Maldives said, well, actually 1.5 versus 2 degrees is the difference to us between being in the ocean and not, right? I don't know for sure that this is the world we're going to live in, but you might end up with trade-offs like, do we have enough energy to allow large population sub-Saharan African countries to develop if we don't decarbonize fast enough? Or do you protect the, territorial integrity of small and developing states, right? It might be the case that the world has to choose between those two options. In fact, I read that the Marshall Islands is already convinced that we're going to do that, and they've bought enough land in Fiji to move the whole population there, right? But the point is like we might have to have really, really make really hard, ugly choices. And it's certainly not a good idea for us in rich countries to say, oh, we can't think about that. We don't want to think about that. Like, we might have to think about those kinds of things, and not just sort of one example.
Yeah, I think even with, I mean, I agree 100% with that. Even within rich countries, you know, it's like it may be that the rich just have to give up some of their money if we want to adapt. I mean, you know, it's just they're just got to pay with tax dollars because only the federal government can build a seawall. They're the only institution that can spend $60 billion on something that doesn't return any kind of stream of income. There's no investment. No private company is going to do that. So the government's got to do it. And, you know, $60 billion is not that much for the federal government, but that's just Houston. You know, what about Miami? What about Boston, Washington, D.C., San Francisco? And these are just the U.S. And so I agree with you. There's going to be some tough choices. I think the people who are trying to use adaptation as a way of delay, that's what they're trying to delay, basically.
I was with you until the last half sentence. So I think I believe strongly in the, you know, be charitable, assume the best in everybody. So, you know, maybe there are some people who, you know, have really deeply nefarious motives and, you know, and just want to stop things at all costs. I think people who are preoccupied with development and don't want mitigation to get in the way of development, I think, you know, they can make a strong argument that the country's fiscal health tracks pretty closely with our growth rate in GDP per capita historically. You know, we basically never run a surplus, right, except briefly in the 50s and briefly during the Clinton administration. And so the main way that we reduce our burden of debt is through growth. And so if you're going to have these big expensive projects, be they mitigation, adaptation, or both, I think you have to take the health of the economy really seriously. And the last quick thing I'll say is just that I think political will in climate discourse is often sort of treated as an afterthought, but it's not a trivial thing. So for example, you know, could you tax the rich a little bit more? Sure, right? That doesn't seem like something that would collapse the country, right? You know, for the record, I think that the U.S. should have a sales tax if they want to raise revenue efficiently, you know, for reasons we aren't worth getting into here. But if you talk about these kind of larger, like international degrowth scenarios, what democratic country is going to elect a government whose platform is we're going to make ourselves poorer to make some other country richer, right? To do that, you're either going to have to get rid of democracy, which I reckon based in history would not go well for the poor, or you're going to have such a totalitarian education system that your citizens vote to be poorer. And that totalitarian education systems also haven't gone well in history. And so the point is I don't think these political will things are trivial. And the health and the polity is tightly connected to the health in society.
I can give you some names of people that I concur saying adaptation and bad faith, but we'll do that offline. We'll do that offline. There certainly are people out there who I think are making that argument, but yeah. But I mean, I guess could you comment on what you think? Like, you know, we were talking before about Chris Wright, who's the Secretary of Energy, and sort of the way he's this frontal assault on renewable energy. If you look at his his Twitter feed, it's just the amount of misinformation on renewable energy is incredible on there. I mean, do you have any thoughts about what motivates? You said you met.
Yeah, I mean, I've met him very briefly twice. So I'm definitely not going to get into a mind reading process. I don't pretend to know anybody's motives. So maybe to comment on on Chris Wright, I would say he's obviously very smart. I think he does understand the basic physics of climate change. If you look at kind of the decadal or more record of his public comments, I think he understands the importance of cheap energy. In terms of the administration's policies, again, I think stopping renewables that are already built doesn't make sense economically. Cutting science doesn't make sense. I don't know which particular department this comes from, but the idea of destroying satellites that are measuring CO2, right? That's if you think there's an argument, that's not the way. That doesn't look like you think you can win it. But I think that there is an argument to be made about, like, if renewables are so market competitive as they seem to be, as you show, do we need to subsidize them at the level that we did under the Biden administration? I think, especially given that we're in a very different fiscal environment, I think that's a totally valid argument to have. But yeah, I would say that the current administration, to the extent that they are doing things that reduce energy abundance, they're not helping the economy. So I guess I would prefer more of a measured approach to that. More if you're going to have a market philosophy to climate and energy.
Oh, well, you're an economist, so I would think that you would agree that given that there are much lower externalities for renewables, we should be subsidizing them, right?
Well, so great question. Arguably, there's positive externalities to cheap energy. So arguably, we should just be subsidizing energy, which we have been, right? Historically, given that there are lower externalities to renewables, there's certainly an economic argument for subsidizing renewables more. But I think in terms of like electricity markets, renewables are so competitive that however we subsidize them, like I would love to see, more R&D into how do we fix cement, for example, how do we fix, jet fuel, because those are the kinds of things that are going to be a lot of pay with current technology.
Yeah, so here's the way I think about subsidies, and I'll wrap up. I'll just make quick. I think about subsidies. Fossil fuels are doomed. Whatever you guys do not go into a career in fossil fuels because you're going to be out of the job at you're 50. They're doomed. The question is, how fast are they doomed? If you subsidize renewable energy, you can wipe out fossil fuels very quickly. Maybe you don't want to do that, but that's that's the knob you have, how fast you wipe them out. If you don't, it's going to take longer, and you're going to have more emissions, as you showed. Cumulative emissions, it's temperature scales of cumulative emissions. You're gonna have more warmer. And so I think that's really the choice as a society have to make, is about sort of like how fast you want to do this. And that's really where the subsidy, in my mind, subsidies come in.
Okay, I can't resist. Can I ask one really, really, really quick 20-second follow-up? So what's your argument or your response to, say, the Václav Schneel's argument that regardless of the prices, it just takes so long to build new infrastructure that energy transition is going to be slow no matter what we subsidize?
Yeah, so solar is not slow to build. You can build a big solar plant in 6 months. A lot of infrastructure is slow to build, but in the U.S., it is extremely slow to build, but that's because we're such a litigious society. It's so hard to build anything. You get sued, you get stuck in court. I don't think there's a physical reason why we couldn't do it I would never suggest like you shut off fossil fuels tomorrow, but by 2050, I think we could largely be decarbonized. And that's kind of and you could have equipment wear out naturally. You're not retiring too much stuff early, maybe a few things get retired early. So I think you can do it. So I don't, even though it looks like it's hard to build, I think you can build stuff faster. Solar is very fast. We'll round up this.
Okay, thank you all for that interesting exchange, and I'm optimistic that there will also be some irresistible questions from the audience. So this is the point where we turn it over to you all to drag the conversation to the best of our time together.
Yes. Okay. I also see it so precisely yes, image purposes of fresh. I actually had two questions. So first, I want to ask, with renewable energy, I'm all for transition to a renewable future, but I do also know that a lot of the material that goes into making renewable energy, like solar panels, is not always extracted in a renewable way. I want to know how you think we can mitigate that. I was also wondering, because another big contributor to climate change is actually like our agricultural industry, how you think it can adapt our food industries to be more climate friendly.
Sure. So those are two completely different questions. The first one about sort of supply chain issues. Let me first start by saying there is no energy source that has no impact. Okay, so you have to understand that anytime you're generating 10 terawatts of power, which is about the amount of final power that society uses, there are going to be impacts. We really have to compare the impacts of extracting, cobalt, and you can sort of use rare earth metals, which I think is probably what you're referring to, which are often extracted in places that are very poor, and people have terrible working conditions. there's going to be an impact. And I think that as U.S. citizens, we need to look at supply chains. And not just for energy. I think all of our supply chains are really suspect. If you have an iPhone or you eat shrimp, frozen shrimp from Kroger, and those are deveined and peeled by basically slaves. I mean, we have a lot of supply chains that are really bad. I think we really need to think about that. And part of it is moving the supply chains to the U.S. Right now, China essentially makes all solar panels, not literally, but they've basically cornered the market in solar panels. We've let them do that. And that was a huge mistake by the U.S. I think we need to really bring some manufacturing of solar panels just for national security back to the U.S. And that would also clean up the supply chain. So also start doing mining here and production here. It would be better than if we're buying everything. But all in all, we just, supply chain, we just need to realize you have to pay more money for ethically sourced stuff. And if the only thing we care about is cost, we end up with very bad supply chains. So the second question you asked me about agriculture, and the way I normally answer this is I say I don't know a lot about agriculture, even though I work at Texas A&M. In any A&M class, there's always 5 students who know way more about anything having to do with farms than me. So I typically don't talk about it, so I'll say something dumb. But I will say that I think agriculture is one of the hardest parts of our economy to decarbonize. And part of it's because farmers are so powerful politically. It's why do we use ethanol and gasoline? It's because of the first presidential primary is in Iowa. And so everybody who wants to run for president has to support ethanol mandate. And so I don't really know a lot about it, but I think that is a really important problem. And I do think there probably are solutions, but we have to be really smart about it.
Yeah. So let's see. Agriculture, I agree, is a very hard problem. There actually does seem to be evidence that as a country gets rich beyond a certain point, the land use for ag actually goes down. And in many places, like Northern Europe, for example, the fertilizer use also goes down even as the yields go up. Now, you probably can't get those things to zero, right, and still make food. So you're going to need some kind of solutions for, for example, Haber-Bosch process to make nitrogen that requires a lot of concentrated energy. And so you're either going to need to find a renewable source of concentrated energy, or you're going to have to find a new Haber-Bosch process. That's as far as I'll go with my limited expertise in ag. And then, I agree that we should be mining more rare earths here. And I think in the short term, that, in the long term, I think we want to be the leaders in whatever the next technology is going to be. That's always going to be good for us. But I think in the short to medium term, there is an argument for not getting off of oil and gas before we're ready to have a secure supply chain in renewables. And I think Republicans and Democrats can probably agree that we need better permitting, more faster permitting, less of a litigious society. And that's an area where I do see some bipartisanship in Congress.
Thanks for your questions. Nobody get a microphone, make it your kids. Hi, my name is Heather Reynolds. I'm a professor of biology here. Thank you so much for modeling this productive civil exchange. My question is about energy density. As I understand it, renewables can't really replace the energy density of fossil fuels. I mean, nuclear maybe is the best competitor in terms of energy density. And so to think that you're going to keep growing the economy on renewables, I think you kind of come back to this idea of degrowth and steady state, because in order to run an economy on renewables, you're going to have to come way down in terms of your intensity of the economy, the number of people, etc. And solar and renewables, they're not truly renewable. I mean, those rare earth minerals will run out too. And just to pile on top of that, the elephant in the room, AI, which is causing a surge in energy infrastructure, high intensity energy power centers being built to power of AI, because we're afraid if we don't come out on top of AI before, other countries do. So when you put all that together, I guess I just want to, assess your response to all of that mix of things.
Sure, I'll take a stab at that. So certainly I can agree with the predicate, which is that renewable energy is often lower density than fossil fuels. On the other hand, you can get all the energy society needs by covering 1% of the planet with solar panels. And that's about the same area as covered by cities. So there's really no physical reason you can't do it. And once you have electricity is the best energy. You just need to have a transmission network to move it around. There's no reason you can't do anything, and no reason you can't grow the economy. So I think that's it. I think it's not correct that switching renewables requires the economy to not grow or constrains the economy. As far as your question about AI, that's really a good question. And I think that if we don't build renewables as fast as we can, we're really going to be in deep something. Because the global production rate of natural gas turbines is about 70 gigawatts. That is not very much power. And we simply cannot build the fossil fuel plants fast enough for these eye-popping estimates. So you better hope we can build renewables, or else the price is going to spike, because that's the only way they'll be able to equate supply and demand. And those people have a lot more money than you do. So they're going to be, whatever the price is, they're going to be buying power. And they'll just raise the price until you can't buy, and that's how they'll set supply and demand. So I think renewables are the answer. It's not does not require us to.
What about the rare earths? Yeah.
If you look at the amount, I have a slide. Actually, I would do it. I have a slide that shows how much of all of the components that we have to dig up. And we dig up billions of tons of coal. And if you look at these rare earths, it's hundreds of thousands of tons. I mean, it's orders of magnitude less. The thing is, once you build a solar panel, it's not like you need to keep mining. That solar panel runs for 30 years. And, if you look at batteries, so look at the battery in your car. There's lead in the battery in the car. It's a 99 point some high number of percent recycled. So at some point, we're going to generate a closed economy where there's recycling all of these things. Once the price gets high enough, that's what they're going to do. And you also see substitution. So the way the market works fantastic for stuff like this. Tesla, for example, they've gone from the traditional lithium ion to lithium iron phosphate batteries. So lithium, iron, and phosphate are three of the most common things in the crust. And so these people make these substitutions. So I'm not worried about that. I think we're not going to run out of that stuff. The market's going to work and substitute that in. And if it becomes expensive, they'll start recycling it. They'll do other things. I mean, clearly you want to have an ethical supply chain, but that does not worry me at all. So
I mostly agree with the rare earth take that we'll figure it out. But let me respond to the other two. I think AI is the energy demands of AI. I think are going to end up being less of a constraint than people think. If you look at even out to like 2030, which the projections, which I don't even know if I believe, are not that big on the scale of global electricity use, but also you can cut. One estimate I've seen is you can cut half of AI's energy use with better code, right? And there's something like 95%, I think, say it was one talk I saw, say energy savings to be found if you do AI more efficiently. And I think because we're such a litigious society, regardless of what our energy source is, we're going to create strong economic incentives for AI companies to either build their own power sources, some which will be gas flares, some which will be renewables, and also to increase that efficiency margin. In terms of your other point, whether or not it's physically possible, it's definitely true that we do not currently have renewable technology for mass air travel, and we don't have renewable technology for decarbonizing cement and steel. And maybe nuclear can do that. Maybe some combination of renewables and batteries can do that. Maybe some combination of fossil fuels and carbon capture can do that. I say let's invest heavily in R&D and let the market figure out which one works.
Thank you. With that, I think let's go here and then we'll come over here. When it comes to your mind.
Hello, my name is Stanley. I'm from Indianapolis and I'm an exploratory major. And I was wondering, do you believe that nuclear power has its sort of place in like energy economy in the future?
Yes.
If it is viable, then why not use purely nuclear? Why exclude wind and solar if nuclear is a viable option? Like, what are the reasons that wind and solar are still have a place in the economy?
Well, okay. So if you don't mind, I'll answer it quickly, and Preston has also an answer. I mean, I think that there's no question that historically nuclear has been tied up in disproportionate regulatory burdens for other sectors. And particularly now that it's gotten as safe as it has, and there's modular nuclear that doesn't take forever to build, we should stop that. We should put nuclear at the very least on a level playing field. And then in terms of, weighing the cosmic differences of, which one has less externalities, which one's density, I think I'm just going to be a free market guy and say, let's just let the market figure it out, right? There's lots of contexts where, maybe you want the lower energy density, but the lower impact. You don't want the radioactive waste, even though it's very small quantities, right? There's maybe other areas where the energy density is more important. Let's put it this way. If you put a price on carbon, right, as a solution to climate change, the market would figure out what the right mix of solar and wind and nuclear is, and who am I to say that that's wrong?
Yeah, I have a very, very, very long answer, which I won't give you. I'll just say very shortly, very quickly. I think that nuclear is an interesting option, but right now the market's not building it. And so the question, whatever people, I talk to nuclear, promoters all the time, and I say, what's your policy? What do we need to do to get the market to build nuclear? Because it's not building nuclear right now. And I think deregulation by itself is not you can't simply say we're going to regulate these plants less strongly. I think that's not what people want. And so I don't know what, so I guess give me a policy and that promotes nuclear, and we'll evaluate at that point.
Thank you. Okay, here in Frank's, and we'll move around to the back.
So you both have been very clear that climate change is an issue in our society today, but the debate is how you treat climate change. So my question is, at what point does it become necessary to give in and reach an agreement to delay the current issue that's at hand?
Well, I think the policy question, right, the policy question is, when do you interfere in the market and how much, right? So right now, the market is producing more fossil fuels and more renewables globally, right? In the US, it's producing more oil and gas, more renewables, less coal. So I think you interfere when, to be trite, the benefits outweigh the costs, right? Climate change does represent a negative externality, right? So I think there's a clear argument for intervening more than nothing, right? The economic development also is really important to well-being and has a lot of spillover externalities for different areas that we care about. And so I wouldn't argue for intervening so heavily that you hurt the economy, in a significant way. I guess this is the answer. And then, as our knowledge or our impacts or our technologies change, the answer might change accordingly.
Yeah, I mean, I would mostly agree with that. I would just add to one other thing, which is that at some point, in fact, we may already be there. The renewable energies are so cheap. The system is just going to switch over in the absence of government stopping it, which is what's happening in the U.S. If you go to a place like China, they're building as much renewable energy as they possibly can, and they're switching to EVs, and they're doing that both because it's good for them, but also because they want to corner the market. We're letting them corner the market on one of the most important economic sectors of the 21st century. And so I think that, we've really reached a team point where I was actually thinking when I was making the slides, it's almost like you don't have to talk about climate anymore. You just talk about energy. You just say, what's the cheapest energy source and how do you get there? That can be the whole bit. And so I think that I'll be sad because I like talking about climate, but I think that you can just look at it in energy. You want the cheapest energy. One of the things I agree that I think that Dr. Burgess said, I think most people don't appreciate as much as how important energy is. I mean, each one of us has about 10 kilowatts of essentially slave labor. You need to have 100 people working for you to enjoy the life you live. 10 kilowatts is a lot of power. And, we just take it for granted. And it's incredibly important. We want the cheapest power. And I think that very soon, it's not already there, very soon will be renewable energy.
So just quick follow-up, how far beyond electricity do you think that goes? Because China's also building a lot of coal, and related to the earlier question, right? Just let me hear your thoughts.
Yeah, so
outside the electric power sector.
right. So electricity is clearly, the electric grid and transportation are pretty easily electrifiable. But then there's things like heat, industrial heat is maybe a little bit harder to decarbonize. That's a lot of natural gas now in the U.S. Maybe they use coal in China. I'm not sure where they get that. I think there are solutions to that also. But you pointed out correctly, I think, that the last, 10% of emissions are going to be really hard to decarbonize, like international airline flights. We don't really know how to do that. And so I think I just don't worry about that, and we'll solve that problem down the road. At some point we'll have to tackle, but there's so much low-hanging fruit between now and there. That's really what we should be focusing on.
We better adapt because those other 40 gigatons are going to keep heating us up.
That's right. And just to be clear, I agree adaptation is important because we need to adapt to the warming we can't avoid.
How about here?
Hi, I'm Lily Brown. I'm studying nonprofit management in our firm called Laser, Indiana. So I know you were discussing New Orleans, and that if we stopped the emissions in New Orleans today, New Orleans climate would only decrease its temperature by 0.1 degrees. I'm just wondering.
Much less than that, sorry.
Oh, much less than that, sorry. I'm just wondering, as a student who is quite frankly very angered by generations above me pushing off climate change for later, why not welcome this gradual decrease of temperature by switching entirely to renewable and stopping it in its tracks, rather than just band-aiding the climate change issue with adaptation? Why do we continue to make climate change the younger generation's issue?
So, can I take that first, please? So, two cons to that. One, I actually, even though I'm the stodgy, almost 40-year-old, moderate right Canadian now, I actually resonate with that more than you think. So, I was something of a social justice activist when I was in high school. Child slavery and sweatshops was my issue, and I became disillusioned with some of the advocacy movement that I was involved in. Not because of that issue, which I still think is important, and I'm glad that we made as much progress as we did. But this idea that the older generations wreck the world, I have a bit of a problem with that, right? Because the older generations sure did give us the emissions that we have, but they also gave us the post-war order and the enormous economic growth and the huge changes in medicine and technology and other things that have made our lives objectively better than theirs. And I remember one time, coming back from a conference of Canadian social justice activists that I've been invited to, and just thinking, like, do I really think that little of my parents? Do I really think that little of my grandparents that risked their lives fighting Nazis when they were my age at the time? And I just don't. And my second response would be related to New Orleans specifically. If it was the case that New Orleans could completely shut off its emissions and have no impact on its quality of life, I would be with you, right? But they can't right now. I hope that they will be able to, as soon as possible, but they can't right now. And so, it's not worth collapsing New Orleans' economy to get a 0.0001 degrees Celsius decrease in their emissions. That would be my response. And I guess my challenge to you and other young people is, I love the energy that young people have, and channel that energy into finding solutions. These are serious problems. Take them seriously. Check your assumptions. I would love to see more young climate activists going to study engineering so that next time Professor Dessler and I are on stage, we're like, cement decarbonization has been solved because one of these students solved it. So that would be my response.
Yeah, I don't have much to add to that other than the last thing you said. You just channel your anger. Don't get mad. Don't get sad. I hate to see people who are depressed, but or do get mad. Don't get sad. And make a difference. The world runs on. The U.S. runs on citizens making their voices heard, and your representatives will make choices based on what they think the people are going to vote for. So get involved.
Okay, we have time for one more, and I was watching for the most enthusiastic hand raise, and I think I would get it back. So you have the 5-on-1 one, the cambias.
Hi, I'm Lillian Goldsey from Carmel, Indiana, and I'm studying policy analysis. And this is mostly a question for the resident economist. Considering that because of our global system, over 20 million people die every year because the free market cannot address their basic food needs, their basic disease prevention needs. Why do you think that what gives you the reason to believe that the free market will allow people to adapt to climate change in these very core countries, of which 90% of the costs incurred from climate change will happen, and over 99% of the deaths from climate change will occur?
Yeah, thank you for the question. I mean, first of all, I'm not an anarcho-capitalist, right? So I don't believe in completely free markets with no regulation and government at all.
You're Canadian after all.
Yeah, you're right. Yeah. I sometimes joke when I don't have a dog in the fight. I'm a centrist Canadian, which means that people on college campuses think I'm a conservative, and conservatives think I want to take their guns away, and that's true. But so back to the market. So you do need some guardrails on markets, but the free market has lifted billions of people out of poverty. I mean, earlier in my talk, I mentioned the predictions about catastrophic starvation from overpopulation and food shortages that we're having in the 60s. Now, government funded R&D played a big role in that, through Norman Borlaug at University of Minnesota. But so did the market. The child mortality rate in just 4 countries has decreased by 2/3 since 1990. And market-based economics has a big part to do with that. So, and not only that, the main attempts to replace market-based economies with planned economies, communism is probably the deadliest thing humans have ever done to each other. Killed about 100 billion people, globally, which is, about 10 times worse than Nazi Germany. So, markets aren't panacea, but they're a hugely important part of our society and our well-being.
Yeah, I'm not an economist. I'm a big believer in free markets. I think that, but I think as Dr. Burgess said, I think markets, there are these externalities, these unpriced things, and the markets fail if you don't fix those, like the impacts of climate change. If you don't price those in, then you don't get the socially optimal results. So I think, you need to have a market with guardrails.
All right, I think that was a great question to end on. We'll probably leave us with a lot to think about on our way out. Let's give the speakers one more round.
Is some